Okay. At equilibrium, a mixture contains 0.25 moles of each of the products, that's carbon dioxide and hydrogen gas, and 0.2 moles of each reactant, and the container is 1 liter. So because the container is 1 liter, then I know that the number of moles is also the molarity. So we have the CO2 concentration is going to be 0.25 molar, and the hydrogen gas concentration is also going to be 0.25 molar. Okay, and I'm getting that from 0.25 moles divided by 1 liter. And the concentration of the carbon monoxide is 0.2 molar, and that's 0.2 moles per 1 liter. And finally, the concentration of H2O as a gas equals 0.2 molar. Okay. So first thing, okay, how many moles of carbon dioxide would have to be added at constant temperature and volume to increase the amount of carbon monoxide to 0.3? So the first thing we need to do is find what the equilibrium constant is. And that would be the concentration of carbon dioxide times the concentration of hydrogen all over the concentration of carbon monoxide times the concentration of water vapor. Okay, so that is going to be 0.25 times 0.25. I could say 0.25 squared because it's the same thing times itself, times 0.2, 0.2, and using the calculator I can get a K equals to 1.56. Okay. So now in order to do the next step, how much carbon monoxide do I have to add? Basically, I want to set up an ice table. So I'm going to CO H2O CO2 and H2. Okay. So I'm initially starting with 0.2, 0.2, okay, got that because basically I'm adding carbon dioxide at equilibrium. Okay, so it's at equilibrium, so I know the carbon monoxide is 0.2, the water is 0.2, and the hydrogen is 0.25. I don't know how much carbon dioxide I'm adding, so that's called 0.25x. So the change and then equilibrium. So they ask for 0.3 moles per liter of carbon monoxide at equilibrium. That means the carbon monoxide went up by 0.1. So the change is going to be adding 0.1 to the reactants, which means I have to remove 0.1 from the products. Okay. Why is it all 0.1? Because the stoichiometric ratios are 1, 1, 1, 1. So that gives me water having equilibrium concentration of 0.23, 0.25 plus x minus 0.1. Okay, I'm going to, my like terms are right here. 0.25 minus 0.1 is 0.15 plus x, and my hydrogen is going to be 0.15. So now I use my KC 1.56 equals the concentrations that I'm given here. So that's 0.15 plus x times 0.15 divided by 0.3 times 0.3, and that's going to change colors. 1.56 equals 0.0225, because that's 0.15 times 0.15 plus 0.15x divided by 0.09. Going to multiply 0.09 by both sides of the equation and then subtract the 0.0225, and I get 0.1179 equals 0.15x. So x equals 0.786 moles per liter, and since it's only 1 liter, it's 0.786 moles. Okay, so just a quick summary. First thing I need to do, since they give me the number of moles, I need to convert that to concentrations. So convert to concentrations. Second thing, set up my equilibrium constant, solve for my equilibrium. Third thing I'm going to do is set up my ice table using my initial values, or the values at equilibrium, except for the fact that I need to change the amount of carbon dioxide by adding carbon dioxide. How much? I don't know. So I say plus x, and then using what I want to get at equilibrium, I adjusted my change values. After I get my ice table set up, I use my ice data, set it equal to my equilibrium, and I solve for x.